Hi, it's Paula J from Secure. Welcome to another episode of Secure Hacks Weekly. So today we're going to talk about cache credentials, something that everybody talks about, but not many people actually know how they work. Cache credentials, or maybe we should say cache logon data, this is a piece of information that when we log on, when the network is not available, we compare with this data, and then this is what makes it possible to log on to the operating system. It is absolutely important to know how they work, and the reason why it's very straightforward, because we've heard from many different customers and so on in many different articles that what you should do is to change cache credentials to 0 or 1. But seriously, in the current time, there is no reason to do it. And I would love to explain how it works. And a very important factor is that we are the first team out there that reverse engineer the whole mechanism, and we would like to talk about it in details. And if there is someone you can ask the question to, it's definitely us. In this episode, I will show you how cache logon data works, what is inside, how we're able to override it, it's possible to override it, and what kind of threat it exposes, if. Okay, so now, let's begin.
Okay guys, so you should see my screen right now, and I have here Freddy Krueger that's gonna log on to Windows 10 client with the password. So the reason why I'm showing you this because we're gonna be obviously working on that password, but the first step is quite simple. Yes, we log on, and we have right now actively logged on to the domain, which means that we did not use cache logon data. Which, by the way, you can always check in the security log what kind of logon type did you use. And each logon type has its own number. If you are interested more, then you can always search within the MSDN by logon type, and you're going to find appropriate information. So what we will do, I just want to show you something interesting related with data protection API. I will open Chrome Pass, one of the nearest of those, quite simple but very nice. And here we can see that Freddy, of course, saved his password in the browser when he was logging on to LinkedIn, and that's kind of a password. Yeah? But whenever we are thinking about logging on with cache logon data, of course, from the data protection API perspective, as long as you log on with the same password, it doesn't really make a difference. But what I would like to show you is that whenever the password changes, that makes a difference. That's the first thing. The second thing are cached logon data passwords. Are they really safe? Okay, so let's have a look. First of all, at that certain point, we're just going to close it. So what we're going to do, we will reboot this machine. And over here, as you see, I have a Windows installation media connected. And we're going to reboot this machine from that installation media. We could do it online. It doesn't have to be offline. Please remember that. The only reason why I'm showing you this way is because it's a little bit easier to explain. It's a little bit more clear situation so that everybody gets, of course, the concept of the cache logon data. Okay, I'm going to restart it right now. And we're going to boot from the Windows installation media in order to be at the stage where we are able to overwrite cache logon data. So that's going to be the situation. In the meantime, here we go. I'm just going to press any key. And we're going to be getting to Windows PE, where I'm going to launch the custom tool in order to overwrite that value in the registry. Because cache logon data, that's simply speaking a value in the registry. Now, what you see in the back, just behind the virtual machine, it's a slide that presents how cache logon data looks like when they are decrypted. Because this is clearly a value in the registry, which I will show you. And we call this value MSDCC2. And this value is absolutely not reversible. So if you're thinking like, can we, for example, crack it? Yeah, answer is yes, you can, but that is actually quite a long process because one of the components of MS DCC2 it's something that we call a DCC1, and DCC1 it's a hash that is calculated on the top of the username and the user's passwords hash. So this is something that was saved in the registry of, for example, Windows XP in the past, but right now this value is a little bit more complicated. So this is MSDCC2. 10,240, this is the amount of iterations that we are running this function. So basically it's a quite a complex value, but on the other hand there is nothing against generating rainbow tables for it, but it's going to be a lot of data. Okay, so we've got this. Next, just repair your computer as usual when we are getting access offline. Troubleshoot, advanced options, command prompt. Okay, so let's move to the D drive. This is the place where our CQ tools are, and QE Secure Edition. This is the one that we are particularly proud of because our team reversed kind of engineered the cache log on data. And this part you can find in the Mimikatz. So what we're gonna do, LSA dump cache, and here we're gonna refer to Windows, the Windows system32 config, and then to system because that's the place where the boot key is, and the Windows system32 config security because this is the place where cache log on data is, and then we're gonna use the switch QE, perfect, to override value that we've got within the registry. Yeah, so that QE created us a pre-calculated value, so MSDCC2, that has been encrypted, not directly but indirectly with the boot key, and put in the registry, so that next time we're gonna be able to reboot, we're going to be actually using a different cache log on data here. So let's have a look. File, settings, what we would do, we're going to simulate a situation where we're going to be logging on with no network, so with the, as we call it, cache credentials. Yeah, so we've got here exit, and we are able to close the console, of course. Here we go, and then we reboot. And at that certain stage, we should be able, of course, to log on with the pre-calculated value, because what's the philosophy? It's just a thing that we've got within the registry. And question is, will we be able to see the password that user stored within the browser? And that is a very interesting question here, because we're going to be logging on, obviously, with the different password. So let's have a look. We are getting there slowly. Here we go, and let's find out. First of all, I want to log on with the password that we had before. Yeah, so password. This is the password. I just press enter, and as you see, this time password is incorrect. Yep, exactly, because this is the value that we changed. Mimikatz. It's gonna be a new password, as you see, and at that stage we are logging on. So cache log on data can be overwritten, but if it's about cracking it, you need really long time. So at least today, who knows what's going to be tomorrow, but currently this is a solution that is considered safe. So first of all, let's have a look at if we can see the user's secrets by running Chrome Pass. And that takes a moment, and the reason why it takes a moment is because we are looking for appropriate master key that we'll be able to decrypt, but unfortunately our password does not allow for that, because it's a Mimikatz password, not the password, and that's why this value over here, it's empty. So that's the first thing. Even though someone overrides cache log on data, this person is not able to get access to our data protection API protected, of course, data. So this is the first thing. Second, how does it look in a case of registry? Yes. Well, whenever we get into the registry and we want to open the security hive, we cannot open it. Well, the reason for that is simple. Here we are just a user, so obviously we cannot. Here we cannot even see basically what is happening with the permissions. So what we will do, we're gonna run the console here, command prompt, with the administrative privileges. So I'm gonna log on over here. And what is really funny, I'm logging on here also with the password Mimikatz, because we have overwritten all of the cache logon data, including domain administrators, for example. Obviously, we all know that domain administrators shouldn't be logging onto the machine. It's just a demo machine. Okay, so we got it. Rec edit. Here we go. And even though here I'm not able to get access to security, and if we find out permissions, we can see that administrators have special permissions. System has full control. Of course, I could take over that particular registry hive, but let's don't do it this way. It's not a very good practice. We're gonna get into CQ tools, and that's the place where we've got psexec -s -i -d cmd.exe to elevate to the local system. That takes a little moment. Here we go. And that is where we are able to run registry, yeah? So rec edit. We could use also the switch to run them, the two of them, but okay, let's keep it clean. And from the local system perspective, oh yeah, you are able to get access to cached logon data over here. And that is the place where we can see the NL $1 value 2 and 3 contains cached logon data. Yeah, so that is what we were talking about, and that value over here, yes, as we see it, that is then encrypted cache logon data by the indirectly boot key. That's why System Hive was absolutely necessary in order to get access to decrypt this value. But of course, we are not decrypting the password. Lovely. And at the very end, let's go to policy secpol.msc. It doesn't matter if it's local or domain, that value is basically the same. And when the policy opens, I will of course show you which value do we refer to in this demonstration. So in the group policy settings, in the local policies, user rights assignment, here in the security options, we've got here a value that says interactive logon, number of previous logins to cache in case domain controller is not available. And as you see, by default, it's 10 logins. So when we refer back to this place, it is indeed 10 logins to be cached. And guys, let's remember that, because we've heard so many different stories about cache logon data. As I mentioned, like, everybody's really talking about, but nobody really understands 100% how it works, which is quite unfortunate. And people here in the policy change this value to 0, 1 or whatever. Yeah, it doesn't matter really. Don't forget that I can always here create a string value, in this case the binary value, yeah, and I can always create the cache logon data for myself. So even though you say 0, yeah, it doesn't matter, because I can create this value and then log on with my data, or I can overwrite this value. It really doesn't matter. So in this case, in security, think about comfort. Yeah, it's good to hear. Okay guys, so this completes our demo part.
Okay guys, so I hope right now this is 100% clear how cache logon data or cache credentials work, and I really hope that you're gonna spread the news, because this is the most misunderstood part in security that I've ever seen. Everybody is afraid of it, but the truth is that not many people but you knows how it works.